All right, so today you are going to be looking at different types of bonds. So atoms are like puzzle pieces that fit together to form everything around us. A chemical bond forms when atoms either share or transfer electrons to become more stable. There are three main types of bonds that you're going to learn about, and that is nonpolar covalent, polar covalent, and ionic. So a bond is something that holds elements together because, as we see on the periodic table, all those elements are pure. But when you see stuff around you, the stuff you're made of, that's not really pure stuff. Like, you're not purely just made of carbon or just made of hydrogen or oxygen. It's a mix of things. So bonds are what connect the elements that hold them together. So of these three types, let's see if it'll let me scroll. We have some info about each one. I'm just trying to zoom in. Okay, so we have nonpolar, polar, ionic. So with nonpolar, the big part to remember is that they share equally. They share electrons equally. So often you'll see something called diatomic elements, and that's like looking at O2 or N2. So what you see in the example right here. Or looking at two nonmetals. That's very important. Every time you have nonpolar, it's always going to be nonmetals, and they both start with non. That have similar pull on the electrons. So think about electronegativity from unit 2. That's the attraction of electrons. They're going to have the same electronegativity. The two atoms will. So again, examples are oxygen gas, so O2, methane, CH4, carbon dioxide, CO2. They all have an equal pull of the electrons. So important properties are that nonpolar do not dissolve well in water. They do not like to dissolve in water. So like wax does not like to dissolve in water. They do not conduct electricity, so they will not help you light up a light bulb. They will not help you charge your cell phone. And they're often gases and have very, very low melting points. So they're low melting solids, meaning they will melt real fast. They will melt at very low temperatures. So like if you were to put wax on a hot plate, it would start melting almost right away. Okay, polar. So do not get polar confused with nonpolar. So polar covalent bonds, you're still talking about nonmetals, but this is an unequal sharing of electrons. So in polar covalent bond, atoms still share electrons. It's just not equal. One element, one nonmetal, is going to be more electronegative than the other. It's going to pull that electron more towards it. So think about someone trying to take a blanket from you in bed, or trying to pull you away from doing something maybe that you shouldn't be doing. So examples are water, H2O. Water is always polar. The oxygen is always pulling the electrons towards it. Hydrogen fluoride, which is HF, ammonia, NH3. And let me see if I can do something real quick and get my pen back. Okay. So if you ever see hydrogen bonded with fluorine, oxygen, or nitrogen, it's always going to be polar. And you can think FON. And when you look on the periodic table, on the top right where fluorine is, it's basically those elements near fluorine. If they're ever bonded with hydrogen, then that is going to be a polar bond. Okay. So, properties of polar. They often do dissolve in water. They can form hydrogen bonds. Like I said, hydrogen bonding with those top right nonmetals that are not the noble gases. And they usually make water sticky. So think about dissolving sugar in water, right? So sugar is the example of polar. It will make the water very sticky and are usually liquids or soft solids. Oh, sorry. So used to touch screen. It's not working on this. Okay, so now let's go to ionic. So nonpolar and polar, we're only focusing on nonmetals. Ionic has a metal. In the word ionic, you see the word ion. If you ever have ionic or ion, you got to think of plus and minus, positive and negative charges. Positive always goes with metal. Negative always goes with nonmetal. So basically, ionic always has metal and nonmetal. Let's just move this over real quick. Won't let me. Okay. So ionic bonds form when one atom gives away an electron. Another word for give away is transfer. And that's why it says right here, ionic bonds transfer electrons. So one atom's going to give it away. The metal gives away. The metal is the one that transfers it. The nonmetal is going to take it. So metals like to give away their electrons. Nonmetals like to take their electrons. So this creates ions. So that's the whole reason ions are made. When a metal gives away an electron, electrons are negative, the metal becomes more positive. So think about if you have a negative person in your life and you get rid of them, you're going to feel more positive. So metals feel more positive when they get rid of those negative electrons. Non-metals really want electrons. They want to take them because they want to have a full outer shell to look like noble gases. So ionic bonds, metal, non-metal, metals transfer electrons to the non-metal. All right. So examples are our favorite table salt, NaCl. Sodium is that metal. I'm so sorry. My handwriting is awful on this. And then Cl is that non-metal. So sodium would become positive, Cl would become negative, and together they bond, creating table salt. All right, magnesium oxide, Mg. Magnesium is the metal, oxygen is the nonmetal. Calcium chloride, calcium is the metal. Cl2, which is two chlorides, is the nonmetal. So anytime you have a metal, it's always going to be ionic bond. Okay, and then we have properties. So crystalline, solids, so literally like a crystal. They look like a crystal, like salt looks crystally. They have a very high melting point. That means you need a very high temperature to melt them. Like to melt salts, you usually need like thousands of degrees, like really, really high temperatures. They do dissolve in water. So they do dissolve in water. And when you dissolve them in water, they will conduct electricity, but only when you dissolve them in water. H2O is water. They will conduct electricity, and they will conduct it very well. So if you ever dissolve salt into water and you see if it'll light up a light bulb, hook up a little wire to it, it will light that light bulb up. Okay, so just wanted to go over some notes with you guys. Now, to summarize those notes, in case I bored you, we have, oh, I'm so sorry, this is not working. Scroll down, please. 1 second. Here, we'll take a little pause. Okay, there we go. Okay, so summary, nonpolar, diatomic, that means like two of the same element, or two nonmetals with the same electronegativity. Electron behavior, they share equally. That's a big one. And then properties, characteristics, do not mix with water. They do not conduct electricity. Polar covalent, usually they start with a hydrogen, usually most of the time, and then they end with a nonmetal. So it's two nonmetals. They share electrons unequally. So one is more electronegative than the other. Dissolve in water, form sticky molecules, do not conduct electricity. Ionic is the only one with a metal. Metal and nonmetal. Electrons transfer, so they move from metal to nonmetal. Dissolve in water, conducts electricity only when dissolved in water. Okay. So we have these very important images that you might see on some practice. You might see on a test question. They just show you what I've been talking about for the last 11 minutes. So here, I'm sorry, guys. I'm like a grandma with technology sometimes. Okay, well, let me zoom in. Yes. So examples of 3 bonds. So nonpolar. If you look at these bubbles, like it looks equal. Like if I cut it down the middle, as close to the middle as I can get, both sides are the same amount. They're the same roundness, same size. That's just talking about equal electronegativity. So both elements are nonmetals and they have equal electronegativity. That means share electrons. Bonding electrons shared equally between 2 atoms. And like I said, so this is chlorine, Cl, and there's 2 of them. So you would see it looking like this. And that's called diatomic. Di means 2. Atomic means atom. So like 2 chlorine atoms. Or you could see it with N2, O2, like the other examples we were looking at. All right, and then we have, here's an example of what polar looks like. So you see that if I split it down the middle, it's not perfectly equal on both sides, right? Like one side's, the chlorine side is way bigger than the hydrogen side. That's because chlorine is the thing pulling these electrons. These little dots are showing the electrons. So that means chlorine is more electronegative than the hydrogen. So chlorine has a slight negative charge. Hydrogen has a slight positive because chlorine's pulling those negative electrons towards it. So that's polar covalent. Bonding electrons shared unequally, so that's unequal sharing between 2 atoms, partial charges on atoms. So like I said, chlorine has more electronegativity, gets those electrons a little bit more towards it. You could think of trying to share ice cream with someone and you're both holding on to it, but one person's getting to eat more ice cream than you are. Okay, then we have ionic. And this is an image. If you Google ionic image, like this will pop up a bunch. So this is, oh, by the way, this is HCl if you saw it written for the polar. Okay, back to ionic. This is my NaCl. Like I said, salt. We like to talk about salt. Complete transfer. So that word transfer. Transfer electrons. So this metal, you see it's positive, is giving its electron to the chlorine, which is now negative. So transfer. Always metal to nonmetal. And this results in an ion, and that's why it's called ionic. Okay. One second. Sorry. So you have this worksheet to complete using the notes. You guys can do part 1, which is just filling in vocab using these notes. Part 2, which is answering these questions. Use your periodic table, use the notes. It's multiple choice. And then part 3, hopefully you should be able to do part 3 pretty easily. It's just saying like how the electrons move, which I just talked about. And then part 4, I did try to help with a little example for part 4. I will go over one. Okay. So look at each formula below. So the compound is the formula. Because remember, we're bonding elements together. They're no longer alone. So formula, compound, same thing, almost. Anyways, based on the elements involved, classify the type of bond as ionic, polar covalent, or non-polar covalent. And we're going to draw the bond, which it is okay if you need to look on Google, but really try to think through it, then just look on Google. Okay. All right. So the first one is NaCl, sodium and chlorine. The bond type, is there a metal? First question you always ask. Is there a metal? Because if there's a metal, sodium is a metal, it's ionic. And then draw the bond. What happens to the electron? So the bond is Na bonding to Cl. Sodium's giving away the electron to chlorine, and I put the cation transfers one valence electron to the anion because metals are cations. Just throw back to unit 1. Nonmetals are anions. Okay. Let's try H2O. So hydrogen plus oxygen. And actually, it's not just one hydrogen. It's 2 hydrogens. So hydrogen, because H2 means 2 hydrogens. Okay, so water, H2O is water, is always polar. Polar. So when we draw water, we have oxygen connected to 2 hydrogens. Oxygen has a slightly negative charge. The hydrogens have a slightly positive charge. And what's happening to the electron? It's unequal sharing. That oxygen is pulling the electrons towards it. Okay, carbon and oxygen, CO2. It's not just one carbon and one oxygen, it's also another oxygen. So carbon plus 2 oxygens. All right, bond type. So CO2, if you look in your notes, That is an example of nonpolar. Also, if you think about electronegativity and where they are on the periodic table, they're very close to each other. So they have a very similar electronegativity. So nonpolar, and if we draw it, I would actually draw carbon in the middle. Same, like very, very, very equal pull of electrons. So equal sharing of electrons. Actually, I believe it's going to look more like this. Okay, fluorine and fluorine. This is called diatomic when you have two of the same elements. So if they are the same element, that means they have the same electronegativity, which means equal sharing of electrons, which means nonpolar. Fluorine bonds to fluorine. Equal sharing of electrons. All right, and then magnesium and oxygen. There's only one magnesium, one oxygen. And remember, step one, is there a metal? Magnesium is a metal. That is ionic, which means, here, let's draw it. I believe that's a double bond. So Mg bonds with oxygen. Mg is giving away its electron to oxygen. Metals get rid of, nonmetals take. That is transfer of an electron. Okay, I just wanted to help you guys out with that part because I'm sure it's been a second, and since you've seen a lot of complex stuff like that, remember, guys, keep working hard on this because you still got past chemistry, and just keep doing the best you can. Okay, so we have short answers part 5, so please do the best you can on that based on this video and your reading. And then a little bonus diagram, I think you can do that because we've already kind of drawn that, but you're also welcome to Google it to see how it is. While you do not have a teacher, Google will be your friend, okay? So also come ask any of us for help, any other chemistry teacher. We're here for you guys.